Here's a quick answer key on practice 1 for solving using the Pythagorean theorem. So for page 1, we're going to find the missing leg of a right triangle for each problem. Problem 1, I'm going to start by writing my formula. A squared plus b squared equals c squared. I'm going to substitute in the length of my legs, which are the two sides that form the right angle. Then I'm going to square those. 12 times 12 is 144, and 5 times 5 is 25. When I add 144 plus 25, I'm going to get 169. And then to get c by itself, I'm going to do the inverse of squaring, which is square rooting. And the number times itself, that would be 169, would be 13 centimeters. Now don't forget that there's another number times itself that would also equal 169, which would be negative 13. But we're going to ignore it since we're talking about a distance, and distance can't be negative. For example 2, I'm again going to write my formula. A squared plus b squared equals c squared. I'm going to substitute in my legs, 9 and 12. These are the two sides that form the right angle. 9 times 9 is 81, and 12 times 12 is 144. If I add these together, I'm going to get 225 equals c squared. And then to get c by itself, I'm going to do the inverse of squaring, which is square rooting, which means that my hypotenuse would be 15 units long. Again, it could also be negative, but we're going to ignore that one. And for example 3, again, I start by writing my formula. I'm going to substitute in my legs, 5 and 10. 5 times 5 is 25. 10 times 10 is 100. And 100 plus 25 would be 125. The inverse of squaring is square rooting. And the square root of 125 is 11.2 if I round to the nearest tenth. And so my hypotenuse would be 11.2 centimeters. Now this makes sense because the number 125 is between two numbers that I know the square root of. It lives between 121 and 144. And the square root of 121 is 11, and the square root of 144 is 12. So it seems to make logical sense that the square root of 125 would be somewhere between 11 and 12, which certainly 11.2 is. And also, I can see that 125 is much closer to 121 than it is to 144, and 11.2 is much closer to 11 than it is to 12. So that's just a logical way to check my answer. So in this section, we're going to revisit our coordinate plane problems, but this time we're actually going to use them to use the Pythagorean theorem to find the distance between 2 points. So in this case, our points are already plotted for us, and we want to find the distance between points -3, -1, and 2, 3. And so I can see I've got a right triangle here because a vertical line and a horizontal line are going to make a right angle. And so the first thing that I want to do is I want to find the length of my two legs. So I've got 1, 2, 3, 4. And then my second leg would be 1, 2, 3, 4, 5. And since I can't count diagonally to find this distance, what I can do is use my Pythagorean theorem, since that red highlighted portion would be the hypotenuse because it's the side across from the right angle. So I'm going to start by writing my formula, and then I'm going to plug in my legs. So 4 squared plus 5 squared equals c squared. 4 times 4 is 16, 5 times 5 is 25 equals c squared. 16 plus 25 is 41. And then I would square root both sides, and I would get c equals 6.4 units. And again, this kind of makes sense because numbers that I know the square root of without needing a calculator would be 36 and 49. And I know that the square root of 36 is 6. And I know that the square root of 49 is 7. And 41 is in between these two. And so that would mean that the square root of 41 would be somewhere between 6 and 7. And 6.4 certainly seems like a reasonable estimate for that. So now let's look at the next one. So now I've got the point -6, -4, and 3, 7, and I'm trying to find the distance between these 2 points. So again, I can't actually count diagonally. That wouldn't make sense. But what I can do is I can count vertically and horizontally, so up and down and left and right. So I could draw a line this way and then this way. And in doing this, I'm creating a right triangle. And what I'm trying to find is this diagonal distance, which would be the hypotenuse of my right triangle. So first I've got to find my legs. So I can count this way, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That would be leg 1, or leg 2, it doesn't really matter. And then I could count this way, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9. That's going to be my other leg. And so then I'm going to use my formula, a squared plus b squared equals c squared. Then I'm going to substitute in my legs. So 9 squared plus 11 squared equals c squared. 9 times 9 is 81. 11 times 11 is 121. And if I add these, I'm going to get 202. And then the inverse of squaring is going to be to square root, which means c will equal 14.2 units. Next, I'm going to use the Pythagorean theorem to see if 3 side lengths could form a right triangle. So I've started the first one for you. So the first thing we did is we wrote down the formula, a squared plus b squared equals c squared. Then we substituted in our numbers. It's important to know that the numbers, remember, if it's going to be a right triangle, the longest side is going to be the hypotenuse. So that means 20 would be the hypotenuse if we have a right triangle. 12 squared would be 144, 16 squared would be 256, and 20 squared would be 400. 144 plus 256 is going to equal 400. And since the Pythagorean theorem worked, that would mean that yes, in fact, these 3 sides could form a right triangle. On example 7, we're going to set it up in a similar way. So we're going to first identify our legs as our 2 shorter sides and our hypotenuse as our longest side. We're going to write down our formula, and basically our goal is to see if our formula works. So let's plug in our legs, 8 squared plus 11 squared, and see if it's going to equal 14 squared. 8 squared will be 64, 11 squared will be 121, and 14 squared will be 196. And when I add 64 plus 121, I'm going to get 185. Since 185 and 196 are not equal, the Pythagorean theorem didn't work, which means no, this could not form a right triangle. So next we're going to go to the last thing that we can do with the Pythagorean theorem, which is to find a missing leg instead of the hypotenuse. So you can see in this example, I actually have the hypotenuse, I have the side that's opposite the right angle, but I'm missing one of my legs. In this case, it happens to be B. So this example's been done, but I just want to talk you through it just in case. So I've got my A leg and my hypotenuse C. So first thing I'm going to do is I'm going to write my formula. Now even though I'm missing a leg, my formula does not change. It's still a squared plus b squared equals c squared. My next step is to just substitute in my values. So 5 is going to take the place of A, so 5 squared, and 13 is going to take the place of C this time because it's the side that's opposite the right angle. It's the hypotenuse. Then I'm going to simplify. 5 times 5 is 25, and 13 times 13 is 169. Now to get b squared by itself, I would first subtract 25 from both sides, making b squared equal 144, and then the inverse of squaring is to square root, and the square root of 144 would be 12 inches. And so my final answer to this equation, or this Pythagorean theorem problem, would be 12 inches for my leg. So now for my next example, I'm missing my leg. This time I'm missing A. So again, I'm going to write my formula, a squared plus b squared equals c squared. I'm going to substitute in the information that I have. So I don't have A, but I know that B, one of my legs, is 24, and my hypotenuse, the longest side and the side opposite the right angle, is 25. I could use a calculator for this. 24 times 24 is going to be 576, and 25 times 25 is going to be 625. I would then subtract 576 from both sides, leaving me with a squared equals 49, and then I would square root because that's the inverse of squaring, which would mean that my leg A would equal 7 centimeters.